Okay, what information can we find out from a velocity time graph? Okay, first of all, when you see a motion graph, make sure you take a look at the y-axis, okay? So you know what you're dealing with. You're dealing with a velocity time graph, okay, velocity in meters per second, not a distance time graph, okay? So make sure you know what you're dealing with. Okay, so let's first of all see what the graph is telling us about the motion. Right, first of all, we can see that we have a line that's sloping upwards. This shows that as time goes on, the velocity is increasing. So the velocity is changing from 0 meters per second, and it's increasing up to 4 meters per second in the first 3 seconds. Now, because it's a straight line, okay, this is uniform. We call it uniform acceleration. So we're accelerating here, speeding up. And then velocity stays the same for the next 2 seconds. So we say constant velocity. And then the velocity increases again for the next second, up to 7 meters per second. And then the velocity comes down steeply, okay, all the way down to 0, okay, over the next 2 seconds. And it's basically at rest, so velocity is 0 for the next 2 seconds, and then we see very steep increase, okay, so rapid acceleration up to 8 meters per second in a second, and then it stays constant for the next 3 seconds at 8 meters per second. Okay, so one of the things we might be asked to calculate is the acceleration. Okay, so if we have a look at the first section, which I've labelled 1, we have the velocity increasing from 0 up to 4 in 3 seconds. Okay, so it's accelerating. So we may be asked to calculate the acceleration. The very first step, okay, make sure you put down the formula that you need. So acceleration is final velocity minus initial velocity, or start velocity, over the time. Okay, well, we can see our final velocity is 4. The initial velocity was 0. And it does that in 3 seconds. Okay, so finally we have 4/3, and then we need to get the right units, meters per second squared. And I'm going to double underline that. Okay, let's have a look at the acceleration 2. Okay, so it's increasing from 4 meters per second up to 7 meters per second. Okay, again, put the formula. A equals final velocity minus initial velocity over the time. So the final velocity is 7. The initial velocity was 4. And it does that in 1 second. Okay, so we can see that's going to be 3/1, which is 3 meters per second squared. Double underline for final answer. Okay, again, A equals V minus U over T. Okay, now be careful with this one because it's actually a deceleration. The acceleration is coming down. So we have final velocity, V, is going to be 0, minus the initial velocity, which is 7. And it does that in 2 seconds. Okay, so we actually have going to end up with a minus number because we have minus 7 over 2. So it's going to be minus 3.5 meters per second squared. Now the reason that it's minus is because the velocity is decreasing. Okay, we call it a minus acceleration, and sometimes we call a deceleration. Okay, so it has a deceleration of 3.5 meters per second. or it has an acceleration of minus 3.5 meters per second. Okay, the next bit, so we have this very steep acceleration, very steep graph, so it's quite a rapid acceleration. So A equals V minus U over T equals, final velocity was 8 minus 0, and it does that in 1 second. So we have an acceleration of 8 meters per second squared